Hi, grade 12s. Welcome to Mathematics and Physical Sciences ACIT Online. My name is Shivambun Shamulo Maiwish, and in this video, I'll be teaching you acids and bases, more especially pH calculations. So before we start with a few examples of pH calculations, I would like us to look at the term pH. So we're going to look at pH. What is pH, right? The first thing that I want us to study here is pH as a term. What is pH, right? So pH by definition, it's simply the it is it is the measure of the acidity or alkalinity of a solution. So that's pH by definition. So it's the measure of the acidity or alkalinity of a solution. So that's a basic definition of pH, right? So pH, it's used to measure the concentration of ions. And you'll see as we proceed with the lesson that those ions that we're talking about, it's hydrogen ions. Why is it hydrogen ions? This comes from the word pH itself. So this pH stand for power of hydrogen, right? So it's the power of hydrogen. So that's why I'm saying pH is used to measure the concentration of hydrogen ions or hydronium ions, right? And therefore, it tells us whether a substance is acidic or basic. So that's what I wanted us to understand. So from now, we need to know that we have a formula for pH that you will be using in your grade 12 year. And that formula is given by pH is equals to minus log the concentration of H3O plus, right? So this is the concentration of the hydronium ion, or it's the same as the concentration of the hydrogen ion, right? So we're gonna be using that formula in our pH calculations, right? And again, obviously you need to know that from pH, we'll talk about something called a pH scale, right? So we have what a pH scale. So this is a scale um, that ranges from 0 to 14, right? And everything that is pH that is greater than 7, this means that the substance is basic, and a pH of less than 7, this means that a substance is acidic, right? And then a pH that is equal to 7, this tells us that the substance is neutral, right? So there's the pH scale. See, it tells you how basic or acidic a certain substance is, right? And we get that from the pH scale. So throughout this video, we'll be doing examples of pH calculations that you might get in grade 12, right? So I would like us to look at the first example. Let's take, for example, e.g., you are told to determine um, the pH of HCl solution with a concentration of 0.02 mole per dm cubed, right? So that, let's say that is your question. right? You asked to determine the pH of hydrochloric acid solution with a concentration of 0.02 mole per dm cubed, right? So how are you going to answer this? So now these are the steps, or these are the things that you need to consider when you're answering these types of questions. So number one, you have to first acknowledge that HCl is a strong acid, right? So number one, we acknowledge that HCl is a strong acid, right? And if it's a strong acid, it means that it ionizes almost completely to form a high concentration of hydronium ions, right? H3O plus, right? So there's one thing that you need to acknowledge. I know that your teachers might not tell you at school, but you need to acknowledge this fact. Why do you want to acknowledge it? Because this statement that tells us that a strong acid ionizes almost completely to form a high concentration of hydronium ions makes us to conclude that, therefore, the concentration of HCl it's equals to the concentration of hydronium ion, right? That's what we can conclude, right? We conclude that the concentration of HCl is equals to the concentration of hydronium ion, just because that this hydrochloric acid ionizes completely to form these ions. So we conclude that, right? And we get this from this equation. We get this from this equation. It's HCl plus H2O, which will give us something like H3O plus, right? Plus Cl minus, right? So we get this from that these HCl will ionize almost completely to form this ion, right? And therefore, now we say the concentration of HCl is equal to the concentration of hydrochloric acid. And I want you to know this. Want you to know this because it will help you answer exam questions. I know most of you just cram these things. You never understood why we used to take the concentration of HCl and we equate it to the concentration of hydronium ion. This is the reason that I'm giving you now, right? So now just because we equated the concentration of HCl to the concentration of hydronium ion, and therefore our pH will be calculated as using the formula pH is equals to minus log, right? The concentration of hydronium, which is equals to. So if you look at the question that we have here, we know that the concentration of HCl will be equal to the concentration of the hydronium ion. Therefore, we're gonna substitute minus log, right? The concentration there is 0.02, and then if you press your calculator, you will get what? What do you get if you press your calculator? So if you press your calculator, you'll get an answer of 1.7, right? 1.7. And this pH confirms that it might be correct because HCl it's a strong acid and therefore its pH is closer to 0. And that gives you confidence that your answer might be correct, right? And then now I want us to look at the second example. So let's take in the second example. You were told to determine the pH of H2SO4, the sulfuric acid solution with a concentration of, let me use the concentration of what? 0.3 mole per dm cubed, right? So this is the question. How are you going to answer this one, right? So let's try to answer it. So one thing that we need to acknowledge here is that this is what we need to acknowledge. H2SO4 is a strong acid, right? A strong acid. And we know that if it's a strong acid, it ionizes almost completely to form a high concentration of hydronium ion. And we see that from this. So it's H2SO4 plus H2O, which will give us, so remember, H2SO4, it's diprotic, right? So it's gonna form 2 hydronium ions, right? And then plus and SO4 minus, right? So from this equation, we can see that this ionizes almost completely to form a high concentration of hydronium ions. And we need to know that because sulfuric acid is diprotic, it gives off 2 hydronium ions, right? Every diprotic substance will give 2 hydronium ions. So that's one thing that we need to know, right? So therefore, still we can associate the concentration of sulfuric acid with the concentration of the hydronium ions, right? So we associate the concentration of sulfuric acid with the concentration of hydronium ions because sulfuric acid is a strong acid and it ionizes almost completely to give off hydronium. So that's why we conclude that the concentration of sulfuric is equal to the concentration of hydronium, right? So therefore, our pH given by that will be equals to minus log the concentration of hydronium, right? Equals to minus log times, so because sulfuric acid gives off 2 hydroniums, right? It's diprotic. Because it's diprotic and it gives off 2 hydronium ions, it means that we're going to multiply the concentration of sulfuric acid by 2, right? So this will be equals to 2 times 0.3 because it's diprotic, right? It gives off 2 hydronium ions, right? And this will be, the answer will be the answer will be 0.22. So this is the pH of sulfuric acid. Hope you get it right. Not, we only could do that if we're dealing with strong acids, right? So we dealt with strong acid now. So I want you to make sure that in your exam, if they're not talking about a strong acid, don't you ever make that conclusion. You don't conclude that the concentration of hydronium is equal to the concentration of that substance if it's not a strong acid. Don't you ever make that mistake. I think I've overemphasized that. So let's look at the next thing that I want you to understand. So I want you to get this one right first. So let's look at what we call the auto ionization of water. So the auto-ionization of water is simply a process where water reacts with itself, right? So here we find out that water reacts with itself, right? And when it reacts with itself, through this equation, we have H2O plus H2O, which will give us one of the two will act as a base and the other one will act as an acid. So therefore, let's say we're going to have H3O plus OH minus. So that's what we have. So that's when water reacts with itself, right? This liquid, right? So that's the autoionization of water, right? So the equilibrium constant for ionization of water, which is known as the Kw. So this is the equilibrium constant for the ionization of water. It's given by, remember, if we have stuff in liquid state, it's not included in our equilibrium constant expression, right? It's not there because it's in liquid state. Therefore, we're going to have these ones that are in aqueous, right? So we're going to have our Kw as the concentration of hydronium times the concentration of OH, right? So this is the equilibrium constant for the ionization of water. So what you need to know is that this Kw at 25 degrees Celsius, which is room temperature, the Kw, it's equals to 1 times 10 to the power negative 14. So that's what you need to know at 25 degrees Celsius. So therefore, concentration of hydronium times the concentration of OH minus, it's equals to 1 times 10 to the power negative 14 at 25 degrees Celsius or at room temperature. So this effect that we're going to use in our pH calculations, especially when you are doing calculations for bases, right? We're dealing with bases, and we're going to look at that in the next example. So now, let's look at that. E.g., for an example, let's take E.g., you are asked to determine the pH of KOH, this potassium hydroxide solution, with a concentration of 0.03 mole per dm cubed, right? So we want to know the pH of the KOH solution. So what we need to acknowledge here before we answer this question is that our KOH is a base, right? So, and what we know about a base is that this thing dissociate to form a concentration of OH ions, right? So it dissociates to form a high concentration of OH ions. That's a strong base, right? So now we know, okay, this is a strong base. Therefore, KOH, you don't need to write this when you're answering exams. I'm just writing down so that you understand what's really going on in this calculation. We acknowledge that KOH is a strong base, right? And if this is a strong base, it means that it dissociates almost completely to form a high concentration of OH minus, right? So this dissociate almost completely to form a high concentration of OH minus. That's a strong base. And we have concluded that with KOH, right? So therefore, if this is a strong base, remember from this, I want you to fully understand these things. From KOH plus H2O, maybe we can say we find this. We find something like okay, this one, when we dissolve it in water. So when it dissolves in water, we find K plus, right? We have K plus in aqueous solution, right? And we have our OH minus in aqueous. So that's when it dissociates completely to form a high concentration of OH, right? So therefore, we're going to say is that, therefore, from this equation, we can see that the concentration of KOH is equals to the concentration of OH minus, because it dissociates almost completely to form a high concentration of this. And we can see that it only forms one OH here, right? So that's the conclusion that we have made. So remember, they want us to calculate the pH, right? And from the information that we're given, and from these conclusions that we just made now, that the concentration of KOH is equal to the concentration of OH minus. This means that the concentration of OH minus is given by the concentration of the KOH. And what is the concentration of KOH? It's 0.3. So the concentration of OH minus is 0.03 mole per dm cubed, right? So now we're done with the concentration of OH minus, right? So, but to calculate our pH, we need the calculation of H3O plus, right? And one thing that maybe I might have left here, let's take this one, it's at 25 degrees, right? 25 degrees, 25 degrees. So if you're not told that it's happening at 25 degrees Celsius, you need to assume, right? You need to assume that it's at 25 degrees Celsius. So now I've added a statement that this is happening at 25 degrees Celsius. So it means that if it's happening at 25 degrees Celsius, what is it that you can calculate here, right? So you have the concentration of OH minus, right? And remember, from what I've written above from the equilibrium constant of water, we concluded that the concentration of hydronium times the concentration of OH minus, it gives you 1 times 10 to the power negative 14, right? So that's our conclusion. So this means that you're going to use this formula, since we have the concentration of OH minus, you're going to use this formula. Let me change the color there. Concentration of H3O plus times the concentration of OH minus will give us 1 times 10 to the power negative 14, right? So in this case, you know the concentration of OH minus. So this will be H3O plus times 0.03, which is equals to 1 times 10 to the power negative 14, right? And therefore, from this, you will get the concentration of hydronium to be, so you can divide both sides by 0.03, and it will be 1 times 10 to the power negative 14 over 0.03, right? So that will be the concentration of the hydronium ion in that potassium hydroxide. And this will give us 3.33 times 10 to the power negative 13, right? Mole per dm cubed, right? So now that we have the concentration of hydronium ion, to calculate the pH will be simple. It's pH equals to minus log the concentration of hydronium, right? And then this will be equals to minus log times 3,33 times 10 to the power negative 13. That will be the case, and the answer will be the answer will be 12,47, right? So the answer is 12,47, and this will give you more confidence because the pH is closer to 14, and we know that everything that is closer to 14, it indicates that we are dealing with a strong base, right? So these are the basic calculations that you need to master first. These are the basic calculations that you need to understand before we go to acid-base titrations. So when you go to acid-base titrations, I will show you how to answer exam questions, right? And that will be part 2 of acid and base pH calculations. Those are a little bit complex calculations, but you need to understand these basic ones first before you go there. Right? I'll see you in the next video when we're doing acid-base titration. I hope you understand the content, and I hope you like it. And if you like it, don't forget to share and subscribe.